Hello everyone. In the last session, we studied about the mechanism of cationic chain polymerization. Now, let us know about its kinetics. What we are going to do here is, we are going to write the rate equations for the steps involved in the cationic chain polymerization. What are the steps involved? The steps are initiation, propagation and termination, right? So, we will consider the rate equations for each step and then we are going to combine those three equations and get a final rate equation. With the help of that final rate equation, we can conclude how the rate of polymerization depends on the concentration of monomers and the initiator. Let us understand it in detail. The first step is initiation. What happens here in initiation? So, this A, that is the catalyst, it reacts with the BH, that is co-catalyst. You know that catalyst means it is a Lewis acid. For example, BF3 or AlCl3 likewise, and the co-catalyst, it is water or methanol, right? So, this co-catalysts donate a pair of electrons to the catalyst, that is Lewis acid, and form a ion pair. This ion pair acts as the source for positive ion, right? Yes. Then this ion pair reacts with the monomer. You have studied this in the mechanism itself, right? So, I have written the general reaction, that's all. So, this leads to the formation of a carbonium ion, and this Ba minus, it is the counter ion and it is always found to be associated with this carbonium ion, right? Yes. Then for this, the rate equation is given by Ri is equal to Ki into molar concentration of M, that is monomer, into molar concentration of H plus, that is positive ion concentration, right? Or you can also call it as concentration of initiator. Fine. Call this as equation number 1. Then the second step, it is propagation. What happens in propagation? Here the successive addition of monomers to the carbonium ion which is formed in the initiation step takes place, right? So, the monomer gets added successively to form a longer chain. See here, so this is the carbonium ion and the monomer gets added to form the chain like this. So, this is the chain propagation reaction, and the rate constant for this propagation reaction is Kp. The rate equation can be written as Rp is equal to minus dm by dt. What is this dm by dt? It is the rate of change of monomer concentration. Fine. Why we have used minus? Because we are going to write the rate equation with respect to the monomer, and the concentration of monomer decreases as the reaction proceeds, isn't it? That is why we use this negative sign here. Fine. Yes. That is equal to Kp, that is propagation rate constant, into molar concentration of monomer into molar concentration of M plus, that is carbonium ion concentration, right. So this is the rate equation for the propagation step. Call this as equation number 2. Then the third step is termination. What happens in termination? The chain growth will be stopped here, right. So this chain gets terminated by the coupling, right. So the rate constant of this termination reaction is Kt, and the rate equation for this step is given by Rt is equal to Kt, that is termination rate constant into molar concentration of carbonium ion concentration, right. M plus ಅಂತಂದ್ರೆ carbonium ion concentration. So this call this as equation number 3. Then so we have got 3 equations, isn't it? So in order to get the final equation, we need to club these equations. How to do it? It is by considering the steady state approximation. According to this steady state approximation, we can assume that rate of initiation will be equal to rate of termination. Fine. Ri is equal to Rt. So we can equate equation 1 and equation 3. So this is the equation 1 and this is equation 3. So from these two we can obtain the value of M plus. See here, molar concentration of M plus will be equal to Ki by Kt into molar concentration of monomer into molar concentration of H plus. So we need to substitute this value of M plus in the propagation rate equation, that is equation number 2. So this is the equation number 2 and we are going to substitute for this M plus. Fine. So we will get this equation after substitution. Okay. So this is the rate of propagation, which is also known as rate of polymerization, right. So this is Kp into Ki divided by Kt into molar concentration of monomer squared into molar concentration of H plus, that is positive ion concentration. So here these are constants, right. These are the only variables. So what we can conclude from this equation is the rate of polymerization is proportional to the monomer square of monomer concentration, right, and it is also proportional to the molar concentration of the H plus ion or positive ion concentration, first power of positive ion concentration. So the rate of polymerization in case of cationic polymerization depends both on the monomer and the initiator, right. Yes. Then let us know about the degree of polymerization in this method. So what is the degree of polymerization? It is the number of monomer molecules present in the given polymer chain, right. So in case of cationic chain polymerization, the degree of polymerization will be same as that of the kinetic chain length, right, and the degree of polymerization is expressed as dP bar is equal to Rp by Rt, that is the ratio of rate of propagation to the rate of termination. So, write the equations. The rate of propagation equation is Kp into molar concentration of monomer into molar concentration of M plus, and the rate of termination equation is Kt into molar concentration of M plus. These M plus and M plus gets cancelled, and we will end up with Kp by Kt into molar concentration of monomers. So, this equation indicates that the degree of polymerization is independent of initiator concentration, and it is directly proportional to the monomer concentration, right? Yes. This is all about the kinetics of cationic chain polymerization. In the next session, let us study about the anionic chain polymerization. Thank you.